Okay, good afternoon, folks. Welcome to our Did You Know You Could series here at the Hurry Institute. My name is Eric Kolachik. I'm the director of the Institute. Brief word about who we are. If you're joining us for the first time, the Hurry Institute for Computing at BU is dedicated to leading integrated initiatives in research and technology development. We target a broad set of disciplines at the nexus of computational and data sciences. This is a quick infographic about the many different groups and activities at the Institute. You can see we have core strengths in cloud computing, security, data privacy, artificial intelligence, and all of this is resting on a network of over 300 research affiliates across a vast spectrum of disciplines. Hariri Institute is positively impacting people everywhere. Here's a quick look at what our program is for today. A very brief welcome from me, and then I'm going to turn it over to Si Wu, one of our graduate student fellows. She's going to welcome you, do a quick icebreaker, and then we're going to turn to the main event, which is Maxwell Palmer talking to us from the Department of Political Science here. This is part of a series. So we talked about statistical principles 2 talks ago, and last talk earlier this week, we talked about training neural net models to perform tasks. Today, we're going to shift towards car ownership and elections. And then finally, we're going to finish up later in the semester with brain-computer interfaces. If you have any questions at any time today for our featured presenter, please do enter them into the chat feature of the Zoom. And I do want to remind you, please do register by Eventbrite for our last series speaker here. Something not to be missed. Okay, so turning now towards the series and today's topic, the Did You Know You Could series provides a venue for people to learn skills that either enable or enabled by computing and data science. The idea is to bring topics you might not even realize you wanted to know about. This was designed to be a brown bag lunch type series, like everything we're adapting in the current environment, but we hope to keep some of that same flavor. You can meet similarly inquisitive people, adding tools to your belt while you do so. This is really meant to be informal, low barrier. So please do drop questions into chat. Feel free to participate in the Q&A afterward and whatnot. I do want to call out that this series is organized by the graduate student fellows at the Hurry Institute, and they've done really a fantastic job of putting together the topics. So for today, our host is Si Wu. Si is a PhD student in political science, and also, as I said, a graduate student fellow at the Hurry Institute. Her research interests include Chinese and American politics, gender and race inequalities, media, and quantitative methodology. For her dissertation, Si is interested in exploring problems and issues that concern the marginalized communities in an authoritarian regime. So Si, it's all yours.
Thank you, Eric, for the introduction. Yeah, I'm really honored to be here and to introduce our featured speaker today. So before we get started, I want to remind everyone to follow the Hariri Institute channels to get the latest updates on upcoming events. Yeah, and then you can see the different channels here. And then just a reminder, this event will be recorded and uploaded on YouTube. As a last note, I'd like to remind everyone that you can customize how you see the subtitles by clicking the live transcript at the bottom of the toolbar. Okay, first of all, welcome everyone. And I want to take this opportunity to get to know everyone a little bit. So I'm gonna ask you some icebreaker questions. So the first question is, what is your field of study? And if you could just type that in the chat. Yeah, type that in the chat, that would be great. Okay, I can see that we have people coming from a variety of backgrounds. We have people from political science, social work, astronomy, engineering, and astronomy, and also political science. So great. Yeah, welcome everyone. And I hope you can learn from today's presentation, even though if you are not a political science major. Okay, and the second icebreaker question is, what degree of familiarity do you have with electoral participation? You can either type in the chat box or you can select the option on the poll. Okay, I can see the poll result now. So looks like a lot of people selected a little. So you are at the right place. Hopefully by the end of the talk, you become a lot more familiar with the topic. Okay, the third icebreaker question is, we're wondering what you want to gain from today's presentation. So if you want to just type that in the chat box, that would be great. So Professor Boas wants to learn about interesting research and policy implications. Yeah, that's a very good answer. Yeah, policy implication. That's, in my opinion, that's a very important question in political science. So what is the policy implications of all the research we do? So yeah, hopefully by the end of it, you'll be able to learn more about the topic. Okay, so now I'm going to transition into introducing Professor Maxwell Palmer. So Professor Maxwell Palmer is an associate professor in the Department of Political Science, a civic tech fellow in the Faculty of Computing and Data Sciences, and a faculty fellow at the Initiative on Cities. So he mainly studies American political institutions, including Congress, electoral institutions, and local political institutions, with a focus on how institutional arrangements and rules impact representation and policy outcomes. He also works as a consultant and expert witness on voting rights, redistricting, and representation. So I would like to remind everyone to, during the talk, you can type any questions you have in the chat box. And we also leave plenty of time at the end of the presentation to explore some more of the questions. So yeah, thank you. And then Max, take it away.
Shared the wrong thing. All right, is that? Sorry, for some reason my sharing is not working. All right, there we go. Thank you very much for having me today. I'm really looking forward to talking to all of you about this project. So this project is based on, or this is a paper that I wrote with my former BU colleague, Justin DeBenedictis-Kessner, who's now at the Harvard Kennedy School, called Driving Turnout, the Effect of Car Ownership on Electoral Participation. And what we're interested in knowing is, how does having a car or access to a car, you don't have to own it yourself, but be able to access a car, affect your ability to vote, and particularly your ability to vote on election day. And we actually came into this question through some voting rights litigation that we were involved with. So the state of Michigan is the only state that has a law that bans campaigns, organizations, independent groups from hiring transportation to bring voters to polling places. And in other places across the country, campaigns will hire drivers and rent vans and will drive senior citizens and others, really anybody who needs a ride, to the polls on election day. And that's a big part of their getting out the vote operation meant to get their supporters to the polls. But Michigan makes this illegal. And so there was a lawsuit brought by some Democratic group challenging this law in 2020. And we were involved in the early stages of this, where we were asked as social scientists to figure out what effects does this law have? Is it keeping people from voting? And there's also a really important sort of policy impact of this, which is not just this law itself, but it can also help us understand how other voting methods, like voting by mail or absentee voting, might reduce disparities that could arise from having access to cars as well. So ultimately, this lawsuit ended up going forward, or ended up settling, and then ultimately getting reversed. So we never actually testified in this case, but we were provided a ton of really interesting data that we normally can't get our hands on to study this question. And because this is a data science crowd, I want to take a few minutes and highlight some of the data we have and the challenges of working with it. And often, I think in voting rights cases, in American politics and political science, often getting big data sets working together nicely is by far the biggest challenge that we face in our analyses. And certainly where I spend the most of my time when I'm starting a new project. So we're combining 3 different fairly large data sets. We have the Michigan voter file, and this actually comes to us from a private data vendor. And there's all sorts of challenges in getting good voting data. But what the voter file is a list of every registered voter in the state of Michigan, a little bit of demographic information, their home address, and then their voting history. Did they vote in recent elections? And this is from 2019, so we're mostly going to focus on the 2018 election in this paper. Then we look at some other ones as well. And just as an aside, this data, the voter file, is actually now available to everybody at BU. There's a university-wide license to an L2, their data vendor, L2 voter file that you can access for research and for teaching at BU for the whole country and not just Michigan. The data that we were able to get that's really I never had access to before is the Michigan auto registration database, every car registered in the state of Michigan, and then the Michigan driver's license database. And the only reason we were able to look at this data was because of this voting rights case. The data was provided as part of the litigation. So there's almost 16,000 cars in Michigan, and for each car, we know the name and address of the registrant, the person who owns it. And there's about 6.5 million driver's licenses, where we also have names and addresses and birth dates as well. And so in order to figure out the impact of car ownership on voting, we need to know who has a car and who doesn't. And so we have to do some fairly complex matching here. And matching public data sets like this is a consistent and big challenge in this kind of research, because people's names are spelled differently and birthdays are transposed, and we don't have some clean identifier that makes it really easy to match some unique key across these databases that are maintained by different sources. So it'd be really nice, for instance, if we had social security numbers for everybody, but that kind of data is almost never available. So we first match the voter file to the driver's license data. And then we also match it to the auto registration data. And we first find that a very, very large share, almost 97% of registered voters in Michigan also have a driver's license. Michigan is a state with relatively high car ownership as well. We find about 90% of voters match to a household with an automobile. And one important consideration in thinking about car access is it's different from car ownership. Maybe your spouse or a parent or a child owns a car and lives with you, and you don't own a car personally, but you have access to that car, either because you can also drive it or they could give you a ride. And so instead of looking at just individual car ownership, we look at, does somebody in your household at your unique address own a car or not? And so we find that 90% of voters have access to a car. There's about 2.5 cars per household. And I'm happy to talk more in the Q&A about how we do this kind of matching and validate it, but it's really important that we get this right. Because if we're not matching people, that can introduce all sorts of bias into our results. We might imagine that people who are harder to match might be less likely to vote for all sorts of reasons. Maybe they passed away and they haven't been removed from this database yet, that sort of thing that could bias our results. So making sure that we're really looking at the right set of people is really important for proceeding. We also bring in some cool data on travel time. So one question you might have is, well, if I live near my polling place, I'm just going to walk there regardless. It doesn't matter if I have a car or not. So how far away I live might impact whether I need to drive to vote. And so we take a random 1% sample of our data and we run them through the Google Maps API to figure out how long it takes them to drive there under normal traffic conditions, how long to walk there to their polling place, or to take public transit. And we can do this because we can geocode every single address in our sample, go from their street address as a string to a point on a map, and then the same thing for polling places to figure out where they're actually located. So we're going to use that data to look at how far away people live from their polling place. So we can start this with a really simple comparison. Let's just calculate the percentage of people who didn't vote in the general election or in the primary election based on whether they have a car or not. And these differences are really big. We find that 36% of people without a car vote in the general election compared to 66% with a car. That's a huge difference in turnout rate. Just from looking at this graph, it might suggest that having a car increases your likelihood of voting or makes it much easier to vote. Primary elections, the elections that happen in Michigan in the summer before the general election, have much, much lower turnout among all groups. But we still see a really big disparity here about whether having access to a car affects your likelihood of voting. But some of you might be thinking, well, yes, these differences might be here, but do they tell us the actual effect of having a car? Because car ownership is correlated with lots of other things that might also affect whether you vote or not. We see really big differences in car access by gender, by age, and by race. And we also see differences in voting by gender, age, and race. And so if young people, for example, vote at lower rates and own cars at lower rates, well, maybe it's not the car access that matters, but maybe it's that they're not getting mobilized in the same way or they don't care about voting in the same way. And we can actually observe from the voter file the gender and age of each voter, and we can estimate their race. But there's lots of other things that we can't observe. Maybe your income, that's going to be predictive of whether you own a car or not, and predictive of whether you vote. Your neighborhood type, your polling place location, and other things that we can't observe. So we're going to look at this in two ways. First, we can control for observables. We can estimate a model predicting whether you vote or not, based on whether you have access to a car, as well as your gender, age, and race. And then we're also going to use a fixed effects approach to control for your location, to say that instead of making comparisons across everybody, we're going to make comparisons within people who live in the same place. And here are sort of four models for the 2018 general election, showing what we think is the effect of automobile access on voter turnout. So just with controls for age, gender, and race, we see a 27.2% difference in car ownership compared to non-car owners or not having access to a car on voting in that election. If we look at people within the same county, so using county fixed effects, we're making comparisons only within the same counties, and that helps account for some urban and rural differences. We see essentially the same thing. But we can actually zoom in further. We can look at people in essentially the same neighborhood, look at their precinct, and say, among all the people who vote at the exact same place, we still see a huge difference. That's the third row here, on whether you're having access to a car increases your likelihood of voting. And we can still be worried about these differences as well. We might say, well, even within a neighborhood, there could be all sorts of socioeconomic differences that might correlate with car ownership and also correlate with voting. And so we can actually, because we have so much data, we have the entire voter file, we can zoom in one level further. And we're going to zoom into your actual address, your building. And we're going to look at people who live in the exact same apartment building. And we should think that people who live in the exact same building should be pretty comparable to each other, at least relative to any other comparison we can make. They'll generally be socioeconomically very similar income levels. They obviously have the exact same distance to the polling place. But this is a little bit of a funny sample because it excludes any single family homes. It requires having buildings where some people, some of the households in that building have access to cars and others don't. But even within that very, very narrowly defined group, we still see a 13 percentage point difference in voter turnout based on having access to a car. That's still a really big difference. And that, I think, is the best comparison we can make, and one that actually lets us get closer to saying this is the causal effect of having access to a car, rather than here's just a correlation between having access to a car and voting. I want to highlight briefly two other things that we look at in this paper, and one of them is the role of travel time. So for our 1% sample, we can look at how far away you live in time from your polling place and compare that to how long it would take you with a car and whatever your fastest non-car method is. So if you have access to public transit, we might be looking at car versus transit. If you don't have access to transit, it's car versus walking. We're just going to break that group up into 4 quartiles here based on the relative travel time change, whether you have a car or not. So for example, this top row shows you for people where the effect of having a car changes your travel time by 9.4 minutes or less. That's people pretty close to a polling place. We still see a 21.6% difference in voter turnout. Among people in the 4th quartile, there's more than a 40-minute difference in voting based on travel, in voting based on in distance to your polling place and having a car or not. We see a really big difference here, about 27 percentage points. So there's some evidence that distance moderates it. That living closer makes having access to a car less important, which we might expect. It's easier to walk. Living further away increases these disparities between people who can vote or who vote and who don't. And then finally, we can break this down also by voting method. And in the United States, most people vote on election day, at least before 2020, where a lot of laws were changed because of the pandemic. But you can also vote absentee or by mail. We call it different things in different places. And so here for each category, we're just going to break down the method by which people cast their ballots. And if you look at the green bars, these are people voting in person. And we see really big differences, 24% to 40% between people who don't have cars and do have access to cars. The purple bars, though, show the absentee voting, that way of voting that doesn't require having a car at all. And we see almost identical rates of absentee voting across both groups. And the same pattern is true here for the primary. Big differences in in-person voting and almost no difference in absentee voting. And that highlights the really important role of absentee voting or mail-in voting as an alternative that can reduce these disparities. As political scientists, we care a lot about participation and about the linkage between participation and effective democratic representation. And we're often interested in policies that increase turnout. We can't give people cars. We can't fix turnout disparities by just giving people cars, at least for the purpose of elections. But we can do things like expand universal mail-in voting. And those sort of policies will reduce these disparities and make it easier for more people to vote and not put this burden on people who have access, who don't have access to cars, to spend a lot more time getting to their polling place and have a much higher level of time cost or inconvenience to vote than people who do have cars. So I'll leave it there and look forward to the Q&A.
So thank you so much, Professor Palmer. And so if you have a question now, you can raise your hand and then you'll be able to unmute and then ask your question. Also, I encourage everyone to turn on your camera if that's possible. Okay. First, Professor Boas.
Thanks. Yeah, this is super interesting, Max. So I was just wondering, did you just get a single point in time, a single cross section, or is there any way to exploit changes in car ownership?
So we just have a cross section here, and unfortunately, this isn't data we can just make a public records request for. We would need another lawsuit to get an update to it. We are able to look at cross elections. We can go back in time and look at the 2016 election. We can look at the 2020 election. As you go further from the date in the voter file, you get some more error as people drop off and miss new registrants and such. And we see very similar patterns in those other elections and in 2020 as well, though with higher levels of absentee voting. But unfortunately, we can't look at, I'd love to get the effect of getting a car, right?
What about like
didn't have a car, but we can't do that.
What about registration date, or can you look at an election that's, I guess you wouldn't know if that's their first car, right? So you couldn't, yeah, okay.
That's the exact problem, is we don't know if you're replacing a car or not, because we don't get to see, there's no record to your past car ownership. It's just the current snapshot.
Okay, Chas?
Thanks. Yeah, I also thought this was really cool and exciting. As someone who's done a lot of get out the vote work before I came to grad school through my union, SEIU, like it corresponds to my experience door knocking and trying to mobilize people to vote. So yeah, this is exciting to see. I'm curious if there is that sort of data from prior elections, if you've thought about the variable of weather, because in my experience, really bad weather also makes it hard to get people to go and vote, and whether a car could be a major factor. If you look at, there was a snowstorm or a rainstorm or whatever in November versus when the primary election was versus the previous election year. Yeah.
That's a great question. We didn't have enough elections to really look at weather, and we're stuck within one state. And so there's lots of studies that look at rainfall, for example, on turnout, but they're comparing across places. And so there's going to be some variation across the state of Michigan, though I think there wasn't, I don't think there's any one, say, big storm in 2018 at least, but it makes it hard to actually make good comparisons there, because also different kinds of areas will get hit differently.
Thanks, Chas, for the question. Next, Ritwik.
Thank you, Professor, for the great talk. You had mentioned early on about the matching between the voter files and the other information, like the auto registration. Can you elaborate a little bit on that process? And
sure. So we take a couple different approaches to matching. I tend to do sort of a multi-stage approach that keeps narrowing down as people fail to match. So some people, in a very large percentage, I think in the 80s, were able to match just directly on name and address. And so when that works, we're done. Or sorry, name, address, and birth date. Other times we can go, we'll use, say, birth year. Dates get transposed sometimes. We do a variety of other checks. People's first and last names get switched. We do matches on that. We do a variety of fuzzy matching that allow for misspellings as well. We are also able to use the voter file and the auto registration database. Those tended to have very consistent spellings between them. We could match people first to a driver's license if we had, say, a birth date and a misspelled, names, and then match them to the car data that way, and sort of use the driver's license as an intermediate file. We also, in the paper, though I didn't include it here in the talk, we look at the effect of having a driver's license as well on voting, and having a driver's license is also predictive of voting at higher rates. Has a big effect, though even among people who have driver's licenses, having a car still has a huge effect on voter turnout. So we tend to try a lot of different things for matching. There's not one perfect solution here, because we don't have, first, we don't really have a very good way to validate it. We also don't have, any good identifiers that make matching easier.
thank you.
Yeah, Professor Eric.
Max, thanks for the talk. You commented at the beginning, how fortunate you were to have this data and to allow you to do these results. If you flip that coin, what weren't you able to do? What data would you like to have that would allow you to do it?
Oh, the dream is to get national data on car ownership, ideally over time. As Taylor mentioned, you could do a lot with getting access to a car, and thinking about that. The challenge here is that data doesn't exist nationally because each state manages their own system. And the commercial data, and I've been able to get access to some commercial data sources on car ownership, which is actually included in the L2 voter file, is very sparse. And what's interesting about it, what we learned about it is it has essentially records of dealership transactions. So it's missing a lot of used car sales. It's missing transfers between people as well. And so you're looking at a very different set of people who own cars than the full car owner population. So we thought about trying to use some national commercial data to do this more broadly, and it found it to be really unreliable and very much a biased data source that we didn't trust the results that would come out of it. But I'd love to get national data on this.
Yeah, next, Mohammed. Apologies if I pronounced that wrong.
That's perfectly fine. Thank you. Thank you, Max, for a great talk. I have two questions. One, did you see any sort of disparity between the urban areas and let's say the suburbs in terms of car ownership? And the other one was, did you consider, I understand there is a cost associated to get geo distances from Google Map API, but did you consider looking at residents who live very close to polling places, let's say half a mile, quarter of a mile, and where you have you considered that to see if there's any sort of disparity still, people who can just walk up to the polling place, and if the car ownership plays a role there or not?
Those are both great questions. So on the first one, there is some variation across the state, though, and we estimate actually separate models for every county in the state, and we find similar effects. They change a little bit in magnitude, but we see very similar results for every single county. So this is true in urban areas where car ownership tends to be a little bit lower, but maybe walkability is higher, but also true, and often a little bit larger in rural counties where you really do have to have a car to get anywhere. So there's certainly, this is not an urban rural story. This is a statewide story that's true in communities of all types. I don't remember looking explicitly just at people who live very close, but in our distance results, we do find, even within sort of similar distances, we find that cars still have an impact. And you can imagine that even if your polling place is walkable, sort of fitting in the act of voting into your day might be easier if you have a car, right? If you're going to work, and voting is in the opposite direction, easy to do with a car, harder to do if you need to catch a bus or get there some other way. So I would expect to still see smaller effects, but still something among, say, a very small band of people living just a couple minute walk away from a polling place.
Great, thank you.
Ritwik, is that still the hand from before? Or do you have another question?
No, I'm sorry. That's a hand from.
No, it's okay. Okay. Okay, if
Oh, sorry, I was going to say, Max, do you have any sense to how this might generalize to other countries? Have people done similar analyses in other countries at all? Or I can think of some of the European countries that maybe have made greater strides away from the auto, or countries whose infrastructure is sort of notably different than ours. Any thoughts on that?
That's definitely outside of my area of expertise. I would expect, other countries that make voting easier in other systematic ways would see much smaller effects. And certainly in places with better mass transit systems that are more widespread, you'd see smaller effects as well. I think there's a couple Northern European countries that might make some more of this data available, though I haven't looked at it. I would say, even though we're only looking at Michigan here, I would expect almost identical results everywhere in the United States, with the exception of states that already have much higher levels of mail-in voting.
Next, Mike.
factors. One is I'm wondering about this matching. If you just matched identically, what percent did you get matching versus going through the more detailed matching, which could produce somewhat more errors, and what finally matching did you end up with of a percentage?
So I think our initial matching, we're getting somewhere in the 80% range, just sort of on exact names, full birth dates and all. You know, it really depends on how you want to sort of define it. So one thing that we see very commonly, you know, there's a bunch of very common misspellings. For instance, are you going to be Mike or Michael? Say you could be Mike in one and Michael in another one, that kind of thing. But your last name is the same, your birth date is the same, your address is the same. Those are things we catch in the fuzzy matching that would not catch in the exact match. We get, so for driver's licenses, we get in the high 90s. Ultimately for matching, for car ownership, we get to, I believe it's just below 90%, which also seems to match car ownership statistics that we were able to get from other data sources, like the American Community Survey. So those are going to be biased in other ways. There's some missingness there as well.
You had 80% on exact matches, and then going up toward 90% with fuzzy.
It's somewhere in the 80s. I don't remember the exact number right now.
Okay. Secondly, did you try to pick precinct or county or whatever and see whether the demographic factors, wealth, race, those types of things were also correlated with voting percentage?
Yeah, so we can look at sort of statewide or in any area differences in voter turnout by race, age, and gender. We also include in some other models some more limited data from this commercial vendor on income and education. I think it's household income as well. So we can try to control for all these things we can see, but there's always things we can't see. And that's why we like this apartment building fixed effects approach. The best is that we're looking at your immediate, you know, upstairs or downstairs neighbor. Those are the people doing much more similar to you than your average, you know, neighbor or average person in your precinct.
Thank you.
Professor Palmer, I have a question actually. So thank you for the talk. And I'm wondering, since we are facing this event to a data science audience, and it's supposed to be like pretty low bar event, I'm wondering if you could like offer any practical tools on how to, because it sounds like you did a lot of data cleaning. So I'm wondering how you were like able to be so optimistic the whole time, dealing with so many issues, and how you kind of like get around with all the obstacles in the process.
That's a great question, and I'm certainly not always optimistic. One thing I really like about this work is I'm working on questions about voting rights that I think are really, really important to answer and to get right, and that have really big implications for people's lives and for our democracy. And one thing I really like about sort of civic tech and being at the intersection of data science and voting rights and civil rights is working on questions that I really care a lot about. And that certainly makes the slog of matching, you know, 7 million people to a card database a lot better, because you're doing something that you think matters in the end, in a question that you really want answered. I think, you know, one thing that's hard about this kind of work is I always feel like I spend 80% of my time on the data, and then the actual analysis is not time consuming. It's not that hard to run a couple models and, you know, interpret them. And so, you know, it's hard that you really don't have any sense of what the answer is going to be or where you're going until you're just about at the end. And that's certainly a challenge.
Thank you. Okay, if there are no more questions, I would like to thank you everyone for joining us today. Thank you, Hariri Institute, for organizing this event. And thank you, Professor Palmer, for sharing us your work. For the next event, I believe Did You Know You Could is called Did You Know You Could Use Brain Computer Interfaces to Restore Speech? And it will happen on March 24. So please register for that event on Eventbrite, and we hope to see you again sometime in the future. Thank you, everyone.
Thank you.
Yeah.